So let's look at state test G. I'm going to go over Yvonne's questions real quickly. There were these 4, and we'll go through and see what we can do with those, and then any questions you guys have. Before we get started, I want to show you something I learned from Helmer's last year, and you might remember this from when you did geometry, but they gave you 3 geometry questions that I had a hard time doing without this trick, and they were all 3 different looking questions, but with this trick, it did all 3 of them, and there were not a zillion geometry problems on here, but I was able to, I believe it was this test, I was able to do 3 of them with this little trick here. So let me show you what it is, and it's pretty great and pretty easy to learn this trick. You may already know it, and if you applied it, awesome, but if you didn't, here you go. So on a parallelogram, okay, on any parallelogram, if you have these sides, like we'll call it X, Y, or W, X, Y, Z, and then we'll call this diagonal 1 and this diagonal 2. It just so happens, make sure I'm right on this. Yes, it just so happens that the X squared plus the Y squared plus the Z squared plus the W squared, square, 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 is equal to the first diameter squared, the first diagonal squared plus the second diagonal squared. And the great part about this rule is you can use it all the time when you're given triangles. So if I'm given a triangle like this, and say they gave me X, Y, D, maybe they gave me this right here, call it A and B right here. All I got to do is just kind of create a parallelogram out of it, which is basically taking this and rewriting it there. And then I know, okay, that's the same X as this. That's the same Y as this. If this little value here is D, then this value right here is D. If this value here is, assuming this is splitting this, right? Okay, so if this is splitting this, like if that's a median, I think that's what they call it in geometry. If that's a median, then this D and this D and this A would be the same. So you could literally say X squared plus Y squared plus X squared plus Y squared, and your first diagonal would be 2D squared, and your second diagonal would be 2A squared. So that little rule showed up on, I think it's problem 10, or I used it on 10 to find it. I used it on 32 to solve it. And then I used it again on 46. And I don't think that they know this trick. And this was last year's test. So if they don't know this little trick exists, they're throwing out these geometry problems of triangles thinking they're going to be clever. I think their goal was to do it 3 different kinds of problems. But if you just take this and redraw a similar triangle on the other side, you've got a parallelogram, and you can apply this formula over and over and over. So if you see a parallelogram like this, or if you see a triangle that you can manipulate, and granted, that would have to be a median, right? If it's not a median, right? If it's doing this, then obviously when you redo it, you don't have that diagonal, right? But if you had a median, which splits this into 2 equal parts, then that median would transfer to the other side as well, and you'd have a situation where this holds. Please remember that. There's not a lot of geometry I know like the master, but that's one worth remembering. And again, if you gave you 15 extra points on this test, made 3 problems pretty easy. And again, I asked him about it on problem 10. I was like, how do you do problem 10? And when he showed me that, I was like, are you kidding me? I can do that 3 times on this one test. So anyway, something to think about. So let's look at number 10. So this was one of the ones Yvonne asked about. And so I'm looking at number 10. It says on triangle AB. Oh, great. So we're actually going to use this. So it gave you triangle AB, C, and it said AB was 16 So it said AB was 16. So if this is my triangle right here on the bottom, AB is 16. That's all I know about it right now. I know that AC is 9, so I know that that's a 9. I do not know BC, so I put an X in there. But then it said the median from C to the line BA, which splits it in half, that's what medians do, has a length of 11. So I labeled that 11, and that made my 16 8 and 8. And boom, right there. I see that triangle. I flip it over. So I take this triangle that I know right here. I kind of flip it around, spin it around, and redraw it. That's supposed to be obviously straight, just crappy drawing. And then that would be X, that would be 9. And I've got my situation, my parallelogram. So that squared plus that squared plus that squared plus that squared equals 16 squared plus 22 squared. So that's the only algebra that I did on that. And then I just simplified. Of course, I have to square it at the end, and it works out nicely. And then it asks me what's the perimeter. So 16 plus 9 plus my new X, which was 7. So pretty easy if you knew that rule. And again, I think the median is kind of the key to that, having that median value. And then he asked about 16. 16. Okay, it says, what is the remainder when divided by x cubed plus x? So what I did is I just thought, you know what, if I'm going to find a remainder, why don't I can actually do the long division. So if you want to do that, knock yourself out. So if you want to, and maybe that's the best way. It would take a little bit of time. That's not what I did, but it would take a little time. So what I just did is I said, well, if it's true for every x value, why don't I just plug in a couple of x values like x equals 2 or x equals 3 and see if I can do it that way. So if I'm doing a remainder problem to me, they're mod problems. Anytime you want to find a remainder of something, it's a mod problem. So if I'm going to find a remainder where the big polynomial was divided by the small polynomial, when x is 2, I plugged a 2 in there. And for the big polynomial, I got this ugly value. And for the small polynomial, I got 2 cubed plus 2 is 10. So I just did a mod problem. And remember the phi thing? Remember when you're doing mods, you're allowed to divide any base by the 10, but you're allowed to divide any power by the by the phi of 10. Y'all remember that with mods? Or did y'all never learn mods? Does anybody have a recollection of mods? Other than 2 weeks ago, did we ever talk about it? I'm seeing a yes from a couple of people. Okay. Well, maybe this is not the best way to do it then. Maybe for you, truly, just take your x squared plus x. Your x cubed plus x, which would be x cubed plus 0x squared plus x plus 0, and divide that. It's not going to be pretty, but you can do it into x to the, well, that's going to be really ugly. Yeah, it's going to be really ugly. But you could technically do it if you had some free time. X to the 87 plus 0x to the 86. I don't really know that I would like that. That doesn't seem fun to me to do that many if the powers were a little smaller. I could maybe give you a small crash course on mods. Okay, small crash course. When you want to find a remainder, okay, what they normally do is give you a really big number, like I'll be nerdy and be ultimately not clever. If you ever see a mod problem like, say, this, what this means is what is the remainder? This is what this is saying. Mod means what is the remainder when I divide this number by this number? Now, clearly, that is a massive number. Your calculator says error. It's too big for your calculator, and your calculator can do 999 places to the left of the decimal. All right? So, huge number. No way you're going to calculate it, but yet they want a remainder. Well, this is a number theory problem. It has no business being comprehensive, except comprehensive means everything on the planet. So I guess, yes, there's some business here. The way you're going to do this is to try to shrink these numbers down. You have two ways to shrink this base. The first way, and shrink it down to a number that you can divide by 12. That's the goal. And by the way, I can move the x in the 2021 to the 2021. I can change places. You know, for the interest of this problem, I'm going to change this to 1967, just so they look different. Okay, so on a problem like this, my goal is to shrink it down. And they're going to give you mod problems. They normally give one a test. So you can expect to see this. I can always, to shrink this number down, either A, subtract 12 from it as many times as I want. So like I could subtract 12 from that and I get 2009. This right here, 2009 to that power, has the same remainder as 2021 to that power. So if you wanted to, you could do that. Although that's going to take you a lot of time as you continue to subtract 12s, right? Pass?
Oh, I got it.
Got it?
I do.
Good man. A little too late for no pass.
I got 5G. Got the vaccine. There you go.
Yeah, you gave me two.
Oh, thanks. Now, the second way, which is much better, I think, for big numbers, is to divide 12 into that. And when you divide it in this case, what, 6, 8, you get a remainder of 5. When you divide it and get the remainder, ignore all the rest of this. You can replace 2021 with a 5. Now it's significantly smaller, except one problem. 5 to the 1967, still a massively big number. Now, at this point, there's another way I can shrink. There's one way. So you got two ways to shrink the base, right? Subtract and replace, or divide and replace with the remainder. Now, and again, we're looking for the remainder when that number is divided by that number. Now, the way to shrink down an exponent is to divide by using this phi number. And Euler, this very bright guy in physics and math, Euler came up with this rule. It's a derivation on one of his things. But the phi of 12 is the number I can divide the 1967 by. Well, phi of 12 is basically this. How many numbers smaller than 12 that are positive? So write down all the numbers, and then I'll show you a shortcut if you can remember it. Those are the numbers smaller than 12 that are positive. How many of those numbers are relatively prime with 12? Now, all relatively prime means is they don't have a common factor. So think, which ones have a common factor with 12 other than 1? Which ones have a common factor with 12? Well, obviously, they both have a 2 in it, right? So not that. They both have a 3, so not that. They both have a 4, but they don't have a 5. This one has a 6. They don't have a 7. 8, it doesn't have an 8, but they both have a 2 in it. This has a 3, so does that. That has a 2, so does that. So how many numbers did you have left? 4? So there are 4 numbers that are relatively prime with 12 that are smaller than 12. That means phi of 12 is 4. And I can divide the exponent by 4 and replace the exponent with the remainder. So I come over here and go 4 into 1967. Goes 4 times, 9 times, 1 time with the remainder of 3. I can replace that with a 3. And at this point, I normally am in pretty good shape because that's 125. And what did I say my very first rule was? You could always divide the what? The base by that number, and that's still the base, isn't it? So can I divide 12 into 125 again? Goes 10 times with the remainder of 5. And once that number is smaller than 12, you're done. So the remainder, when that is divided by 12, is 5. Y'all seeing that? Well, I can do that with this problem. So on number 16, check out it. If I just plug a 2 in, now granted, I'm going to have to do a couple things. If I plug a 2 in, I can look at this into this ugly polynomial. So I plugged it into the x ugly polynomial and then the smaller one I was dividing by. And when I did that, the big polynomial, the one that was like x cubed, x to the 87, whatever, and x to the 42, that was huge. I didn't want to add that. I don't know what that is. Good night. I'm not going to add that, multiply that out. But I plugged it into the small one and got 10. So basically, I'm dividing this by 10. Well, what did we say we could divide any exponent by? The phi number. What's phi of 10? 1, 2, and then I'll show you the trick. I know I've been saying that. So how many numbers have a common factor with 10? That does, that does, that does, that does, and that does. How many don't? 4. So I can divide 4 into the 87, and that goes to the leaves a remainder of 3. 4 into the 42, remainder of 2. 4 into that, remainder of 3. 4 into that, remainder of 1, and that's just a 1. And now the numbers are small enough to actually do the math. So I get 8 and negative 8 cancel, 4 and 2 and 1 is 7. As soon as I'm smaller than 7, I'm done. Okay? Now, the next part, just to kind of verify something, as I went over here, the question was, if you look back at it, what is the remainder? So the remainder was, I got 7 when x is 2, but bottom line is, I got to figure out to make sure this works here. So it worked on that first one, but I went ahead and did the same thing with 3, except when I do it with 3, just to make sure, when I do it with 3, that's not 10 anymore. It ended up being 30, and this ends up being this. So my mod of 30, that's a little bit harder to calculate, so I use this trick. A phi number can be found this way. Take the prime factorization of the 10. 2 to the 1, 5 to the 1. Ignore the exponents, whatever it is. Ignore them. And then you take the 10, you write it down, and then you take the 2 and the 5 and you make fractions with the 2 and the 5 on the bottom. And then you take the 2 and the 5, reduce them by 1, put that number on the top, and then simplify. And there's my phi number. And it's a little easier than writing all the numbers out when you start getting bigger numbers. So with like a mod of 30, if I want to find phi of 30, rather than write out 1 through 29 and start canceling crap, all I got to do is go, what's the prime factorization of 30? 2 times 3 times 5. Ignore the exponents, which there aren't any. Write out the 30, and then make a fraction with the 2, the 3, and the 5. Reduce by 1, reduce by 1, reduce by 1, and multiply it together. 30 cancels. My phi number is 8. So then I can divide 8 into that. It goes 10 times with the remainder of 7. 8 into that. It goes 5 times with the remainder of 2. 8 into that. It goes 3 times with the remainder of 7. 8, well, can't divide it into that. And at this point, a bunch of junk cancels. I can add that stuff up. So bottom line is I got 7 on this one, and I got 13 on this one. So I went back and looked at my answers. Remember the answers for this one on number 16? So which of these, when x equals 2, take a look. This is what I got right here. I know this is a little tricky. So here's my work. I got 7 here. So I plugged 2 into all my answers, and the only one that gave me 7 was the x squared plus x plus 1. And then I plugged 3 into all the options for the answers, and the only one that gave me 13 was x squared plus x plus 1. So that gave me confidence that the answer was x squared plus x plus 1. And I know that seems like a lot to do, and it probably is. You can look at my work. It was not a simple thing. But if you knew how to do a mod problem, when you start seeing the word remainder, if that triggers mod for you, you can just create problems that are mod problems and probably do them pretty quickly, I think. But just remember those 2 rules about dividing the base to shrink it down and dividing the exponent to shrink it down. And a lot of times, I saw a problem on the Algebra 2, and it might have been on one of your comprehensives too, that just said, what's phi of 150? And you're just supposed to know what the phi number means. But you could do it. So like if I just randomly gave you something like phi of 150, how does 150 break up? 10, 15, 2, 5, 5, 3. So you've got a 2, a 3, and a 5 squared, right? Right? So what is your rule for the phi number? How do you find it? Copy the 150 down. Ignore the powers, right? Write 2, 3, 5 at the bottom of the fractions. Decrease them by 1. And then just simplify. So that 10 cancels with that. That 3 cancels with that. And you get 8 times 5 is 40. So phi 150 is 40. So if they only asked you a phi number, you could do that. They've asked that multiple times. But if you are ever simplifying a mod, you can divide that number into the exponent and replace it with the result to really shrink a number down a lot. All right? So that was 16 and then 38. You want to jump to 38. Said the number blah is a root of what? We've certainly not done a lot of that. Okay, here's what I did. It's not pretty, but this is what I did. I set it equal to some value of x. And this is kind of a harder problem than I'm used to seeing. Normally, you see stuff with square roots. But what I do is I just say, okay, I don't know what that's equal to, but it's equal to something. So I just name it x. And then what I do is I try to get rid of the cube roots by like cubing, or if it's a square root, by squaring. And then when I'm done, I go back and get x by itself, if I can. But this particular problem, I didn't have to do that because on 38 it said the number blah is a root of which of the polynomials. So what I'm going to do is I'm going to basically turn this into a polynomial. I'm saying if x is that, if I cube both sides, I'm going to end up with a polynomial. And the solutions to a polynomial are x. X is that. So I'm just going to cube both sides and make it a polynomial. It's kind of like me doing this. If I told you that 2 was an answer, if I cube both sides, isn't x cubed minus 8 a polynomial that has x equal 2 as an answer? So that's literally what I'm doing. But remember our trick for cubing a binomial? We learned it on strange manipulations. You remember how to do this? Cube the first, cube the last, 3 times the product times the sum. Y'all remember that? Do you remember how when you square a binomial, you square the first, square the last, and go 2 times the product? Y'all remember that? That was just a binomial expansion rule we learned when you're squaring. Well, when you cube, the little trick is rather than use Pascal's triangle, it's cube the first, cube the last, and instead of going 2 times the product, we go 3 times the product times the sum. It's just a little shortcut. Check it out. If I go 3 times the product of these 2 numbers times the sum of these 2 numbers, what is the sum equal to? Cube root times cube root, I get 1 big cube root, which is 81 minus 17. Well, guess what 81 minus 17 is? A nice perfect cube. That perfect cube becomes a 4, and I end up with 3 times 4 times x, which is 12x. This, when I cube that, gives me 9 plus root 17. When I cube that, I get 9 minus root 17. And when I add those all together, the roots cancel, and I get 18. And there's my polynomial right there, which was whatever letter this was. So I had to do a little bit of clever stuff, but that little rule right there shows up a good bit throughout these problems. And then that was 38, and then 46 said in triangle ABC, there we go again. Back to this problem, see if you can see it with new eyes. With 46, it told me if AB is 3, so this is triangle ABC. So they gave me this part right here. Okay? So it says ABC is formed by the vertex 8, 3. Hold on. Oh, that's 47. Sorry, 46. AB is 3. So that part's 3. BC is 4. That part's 4. AC is 6. So I know those three sides right there. And if I know that, it says BC is extended. So BC is extended past that to point D, so that CD is equal to BC. So if that's a 4, this is now a 4. Okay? And then it says find AD. So find this right here. So basically, there I go. Look, I have a triangle with a median. And if I have a triangle with a median, I can take this and swing it around and relabel everything. This missing side is X, that missing side is 3, that's 4 and that's 4. If this is 6, this is 6, and I've got that parallelogram rule again. And I can keep doing this all day if I can turn their situation into a triangle with a median. And again, I don't think that was their intent, was to create this parallelogram rule 3 separate times. That just does not seem normal for these, for the two women who write this test. They're usually more creative than that. So they, I don't think, know of this rule, or they just missed the fact that you could do it this way. So all 3 of those problems we mentioned, I did with the exact same thinking. So square, 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 add them up, 12 squared, 8 squared, set them equal to each other, and bada bing, bada boom, you are done. What do you have? Those are Yvonne's questions. Anybody else? Come on, talk to me, guys.
$24.
24? All right, so we're looking at 24, which I circled. I don't know exactly why. Oh yeah, I circled as something that I thought you could do. That was one of those that was not a bonus. So 24. So it said you have a coin, basically. The probability of heads is 0.8. So the probability of heads is 0.8, which means the probability of tails would have to be 0.2, right? So if that's the case, on number 44, it said, what's the probability that heads comes once? So if I have one head, that's 0.8 once. But if I flip it 10 times, that we would have to assume that 9 of them are what? That 9 of them are tails. But I can't just stop there, because it didn't say I was going to get a head and then 9 tails, right? I could get tails, head, and then 8 tails, or tails, tails, head, and then 7 tails. The order could be different. So how do I count the order? 10 factorial, 1 factorial, 9 factorial. So that just ends up being a 10. That ends up being a 0.8, and that ends up being a 2, 9 over 2, 10. But I just simplified. I noticed the answers were really ugly looking. They weren't simplified. So I said, well, let me just write it all in terms of 2s and 10s. That 10 over 9 is the same thing as 9 2s and 9 5s. And that let me cancel a bunch of those and get it down to 8 over 5 to the 9. So I guess looking at the denominators and seeing that the denominators on that had 5s in them, most of them, made me think, oh, let me take that 10 and rewrite it. Otherwise, it was a little tricky, but I just broke it all down and cancels what I could cancel. Anybody get that one? Good. Yeah, that to me is something that we can do on a probability. If you got, and by the way, if you got this, then great. If you got that and still missed it, whatever. That's great to me. At least you know the math. I mean, I would hope that you get it right, but sometimes getting to their dorky looking answer is annoying. But think just creatively. If you can cancel some 2s, and there's some 2s in there, try to break it up. They're going to do that a little bit because you don't have a calculator, and they really don't want you to have to actually find this decimal. But anyway, if you got to there, I'm certainly happy you learned the math. If you miss it on the test, it is what it is. Yeah.
Like the decimal that it gives you into fractions, like 4/5 and 1/5, or 8/10 and 1/5. So then the 10 will cancel, and you get 8.
Oh, yeah, good point, yeah.
5/10.
If that's a 4/5 and that's a 1/5, you've already got 5s, don't you? Yeah, that's true. That would have certainly led you to the promised land a little bit easier, right? Definitely, yeah, because you would have had 4/5 right here and 1/9 and 5 to the 9th. Yeah, that would have been really easy to see. There's your 5 to the 10th, which one of those is going to cancel and leave you what? 8 over 5 to the 9th? Yeah, that would have been much, much better. Yeah, this is me in teacher mode with the 10th. What else you got? Anything you missed you want to talk about? And it could be odds too, because we never talked about odds yet.
Number 9.
9. All right, number 9. It said let F be this and G be that. What's the minimum distance between the graphs? Okay, so unfortunately for you, you guys don't know calculus because this is a minimization problem. But I believe that I made the key out without calculus. No, I didn't. Yeah, the only way I knew how to do this was to take a derivative, which is unfortunate. So I really don't know how to give you a crash course on that. So that's what stinks about being a junior at these tournaments is you don't know minimization, or it's actually called optimization. But basically, taking a derivative is finding a slope, which normally maxes occur when the slope of the graph is 0, or mins occur when the slope of the graph is 0. So if you can take a derivative of a function that represents distance, then you can find out where its slopes would be 0, and the slopes are either maxes or min. So what I did is I found that distance, took a derivative of it, set it equal to 0, and got the x value where the distance would occur. And then I plugged it back in to the function and found out that minimum distance. Now, I didn't do a check to see if it was a maximum, but my thought was if they're going to give you this problem, they probably meant it to be a min, although very likely it could have been none of these. So I probably got a little sloppy, but sadly, we don't know how to do a derivative. And I don't know that that's worth taking the time. Although you will learn how to do derivatives starting Monday, although we will not be talking about much application. We're just going to do the mechanics of derivatives. We'll leave the application to your calculus teacher. What else you got? 50? Find the y-coordinate of the y-intercept of a line with an x-intercept of 3, 0 and a slope of -5/7. So if I'm finding the y-coordinate of the y-intercept of a line, what do I need first? If I want the y-coordinate of the y-intercept of a line, what do I need? I need the line. So what do I do to find a line? A point and a slope. So I'm going to find the point, and the point is 3, 0. So I'm going to go y minus y. So y minus the 0, x minus the 3, plug the slope in, and I get my equation of the line. Now, once I have the equation of the line, how do I find a y-intercept? The y-coordinate of the y-intercept. Well, what's a y-intercept? A y-intercept. Every y-intercept has what coordinate? X would be 0, right? So you'd have 0 something. So I'm just going to plug a 0 in for x, and then multiply that together. So there's your y-coordinate of your y-intercept, because y-intercepts have x equals 0, of this line. So it's kind of maybe worded a little ugly, I guess, but yeah, you can do those. What else? Everybody get 48? Everybody get 44? not seeing a lot of knots. On 44, what do you know about trig functions? A trig function, if the reference angles are the same, is going to give you the same value. So if I say what's the same as sine of 38, the sine of 38 is going to have the same absolute value as everything that shares that. But those aren't the angles, right? 38, so sine of 38 is going to be the same as sine of 180 minus that, right? But what's going to be different about these bottom two? Like sine of 218 or sine of 322. These are going to have negatives. So if these yield positives, these yield negatives. So this would be the same as that, but it would be the same as negative that, because you'd have to negate that to make it positive. But that's the signs. So any one of those could have actually worked on 44, but you'll notice none of those did work for 44. It was E. So then I go to cosines. Well, what have you learned about sine and cosine? The sine of x or theta is the same thing as the cosine of 90 minus theta. So you can do the same thing with cosines. That means cosine of 52. And if 52 is the reference angle, right, 52, then you can do the same thing over here, except where is cosine positive? Here and here. So cosine of 52, cosine of 128, cosine of 232, cosine of 308. But you would have to negate these two to make them match cosine of 52, because it's only positive there. And when you do that, you end up with cosine of 308. Those are the same. All right, guys, make sure you check your assignment sheet and do that next test. And we'll see y'all tomorrow. What?
You gave me an 8 out of 10, I think. Like you said it was 9. Unless I was looking on it, I don't know.
Oh, yeah, I have my
I mean,
scale.
it's okay,
No,
I'm
you're
just
totally,
like-
no, you're right. It should be a 9. I went 90 to 100, 100 to 110. I didn't look at the right one. Yeah, I'll fix it.
Thank you.
Yeah.
Should I have gotten 1 point for this?
Give me 2 seconds.
All right, that'll work.
And I will